All right, guys. Any questions over any of the assignments so far? Any questions over the homework assignments before we start looking at today's lesson? Now, what we're doing today is going to be very similar to how we finished the lesson yesterday, but one main difference. Because yesterday, when we talked about solving these logarithms, we had a single log equals a number. And really, that's what we need, especially if we've got just a number with no log attached to it. We need the logs by themselves, and more specifically, we need exactly one log. One log by itself equals the number. Now, one of our properties with logarithms stated that if we have two or more logarithms added together, we can rewrite it as a single logarithm with what's inside being multiplied. So whenever we have two logs with the same base being added together, we can rewrite it as a single logarithm with what's inside the two logs being multiplied together. So log of 2x plus log of x minus 5 is equal to 2. We can rewrite it as log of 2x times x minus 5. And then we can go about solving it similar to what we did yesterday. Now at this point here, we're going to put both sides to the base of what? Because even though it's not written, this logarithm's base is understood to be 10. Because with log, if it's not written, it's understood to be 10. So we're going to put both sides to the base of 10. So 10 to the log base 10 is going to simplify out, leaving us with 2x times x minus 5 is equal to 10 squared. Any questions on any of this here? Now for the left-hand side, we can distribute this out. 2x times x is going to be 2x squared. 2x times negative 5 is negative 10x. And 10 squared is 100. Any questions on any of this here? Now at this point here, we do have a quadratic. We know of a quadratic because of the x squared term. So we need to get this equation equal to 0. So what we can do is subtract 100 from both sides, telling us that we have 2x squared minus 10x minus 100 is equal to 0. Any questions on how we got to this point here? Now at this point here, we do need to find the values of x that will make this be 0. Now we can factor it, we can graph it, or use the quadratic formula. What do we want to do first? Graph. So we can pull the graphing calculator up, hit y equals, do 2x squared minus so 10 and negative 5. So we can graph it here. We do see that it crosses at 2 spots. If we go second graph, when x is negative 5, the y value is indeed 0. If we scroll down, when x is 10, the y value is indeed 0. So we had x is equal to negative 5, and x is equal to 10. Any questions on any of these here so far? Nice. Now, one thing we need to do is we need to check and make sure that these both work. Because one of the things that we cannot have inside the logarithm is a number that is negative or 0. Now, it's not talking about the value of x that we have, because negative 5 could work. But if we plug it back in, and the end result of simplifying in both of these here is a negative in either or both spots, that does not work. So if we look at negative 5, we would have log of 2 times negative 5 plus log of negative 5 minus 5 is equal to 2. And if we simplify these down, 2 times negative 5 is negative 10. Negative 5 minus 5 is negative 10. So when we plug negative 5 back in, the numbers that end up in the log in both spots is negative. So it tells us that x equals negative 5 is an extraneous solution. It doesn't work. And we could try plugging it in. Log of negative 10 plus log of negative 10, domain error. We cannot have it inside the logs. Now, it's not so much that the x being negative 5 is the issue. It's more that when we simplified it, these both turned out to be negative numbers. We can't have that. Now, it could be the case, because we did have one on the homework, where we had 2 negative numbers as the solutions. But when we plugged them back in, the numbers that worked out for here and here or inside the log was positive 9. That does work. So it does. There are cases where it can work. Now, we can do the same thing with 10. We'd have log of 2 times 10 plus log of 10 minus 5 is equal to 2. Guys. And now if we simplify it, we'd have log of 20 is equal to 2. Guys, let's keep the volume down. Let's focus up here. Now, in both spots, log of 20 is positive and not 0. 5 is positive and not 0. So these do work. Now, we could try plugging it in and say log of 20 plus log of 5, and it does indeed give us 2. So 10 does work, and our solution is that x is equal to 10. We only have one solution for this here. Questions on any of this here so far? Are you ready for the next one? Here, we have log base 6 of 6x plus log base 6 of x minus 1 is equal to 2. Now, we can rewrite this as a single logarithm, log base 6 of 6x times x minus 1 is equal to 2. Questions on any of this here? Now, what can we do next? What can we do next? We need to put both sides to the base of 6. Because our 6 to the log base 6 will simplify out, leaving us with 6x times x minus 1 is equal to 6 squared. Any questions on this so far? Now at this point here, we can distribute the 6x. 6x times x is going to be 6x squared. 6x times negative 1 is negative 6x. And 6 squared is 36. Now again, we have a quadratic, so we'll need to get this equal to 0. So we can subtract 36 from both sides, telling us 6x squared minus 6x minus 36 is 0. Now at this point here, we can factor, we can graph, we can use the quadratic formula, we can use any of these methods. Now normally, if we do have a number in front of x squared, we'll have a fractional solution. But is there a greatest common factor between these three terms? 6. And if we factor that out, it would make the number in front of x squared go from 6 to 1, just x squared, so we won't have fractional solutions. So again, just like the previous one, we can graph this. We can say 6x squared minus 6x minus 36 and hit graph, and we see that it does indeed cross at 2 nice points. And if we go second table, well, one of the solutions is -2, and the other is 3. Now, most likely, between these two solutions, which one do we think will not work? -2. And part of the reason is, well, in both places, we don't have a setup that will offset that negative. Because if it had been, say, -6x and 1 minus x, there's a good chance that it would offset and it could work. But here, if we do plug -2 in, we have log base 6 of 6 times -2. Plus log base 6 of -2 minus 1. And if we simplify each of these here, we get log base 6 of -12 plus log base 6 of -3. Because we do have negatives inside both logs, this here is not going to work. Now we can try it with 3. Have log base 6 of 6 times 3. Plus log base 6 of 3 minus 1 is equal to 2. Now at this point here, if you just wanted to plug it into the calculator and check to see if this works, it would tell us that it does. If we simplify it by hand, we have log base 6 of 18 plus log base 6 of 2. They're both positive, and this actually does give us 2. So the only solution that does work for this here is that x is equal to 3. Questions on any of this here? We good with having 2 logs that are being added together? Because once we get the process, we kind of understand how this works, yes? Now we're going to skip the next 2. Because if we have an understanding of how this works, I want to go on and look at the other type that we have, where we have 2 logs that are being subtracted. Now again, we're going to need to rewrite this as a single logarithm. Now with the first ones, if we had addition, we can rewrite it as a single log with what's inside being multiplied. If it's subtraction, we can write it as a single log with what's inside is being, yeah. So here, we're going to have 3x minus 2 over 2 is equal to 3. Now, because it's not written, the base of this logarithm is understood to be 10, guys. Now we're going to put both sides to the base of 10, because this here will simplify, leaving us with 3x minus 2 over 2 is equal to, well, 10 to the third is 1,000. Interestingly enough, 10 to whatever the exponent is, the exponent will tell us the number of zeros that we have. Now we can't really cancel out the -2 and 2, but it would be nice to simplify that 2, to simplify that fraction. Well, what can we multiply this by to get the 2 in the denominator to simplify? Because 2 times 1/2 is 1. Or really, we're saying that we have 2 over 2 times 3x minus 2. Well, the 2 divided by 2 is 1. So we just have 3x minus 2 is equal to 1,000. So really these cancel each other out. Any questions on how we got to the fact that 3x minus 2 is equal to 1,000? What can we do next? Yeah, I mean, we could subtract 1,000 and then graph it to see what it is. But since x is not to an exponent, we just had 3x. We can just solve for the value of x. So we get 3x is equal to, well, if we do something to one side, we've got to do it to the, yeah, yes. I completely forgot to do that, but when I added 2, I remembered it. So we add 2, we should get 2,002. Divide both sides by 3. Now will 3 divide into 2002 nicely? No. So we get 2002 divided by 3. Divisibility by 3 is kind of nice because if the sum of the digits is divisible by 3, then the number will be also. Yeah. Questions on how we got to the value of x? All right, guys. Questions on this here? Now, at this point here, we can check to make sure that this works. We can plug it back in. So we can say log of 3 times 2002 over 3 minus 2 minus log of 2 is equal to 3. Now we could type this onto the calculator. I could say log of 3 parentheses, guys, 2002 over 3 minus 2 minus log of 2. And if we type this all in, we should get 3. So it does work out. Huh? I would check it, especially if we do get a negative, or with some of these here, to make sure that they do work. With the exponentials, where we start out 2 to the x equals 7, any of those are going to work. Any value of x works for exponentials. Logarithms, we have to be careful to make sure that the number inside the log, when we calculate it, that either one of these does not become 0 or negative. Because here, this would cancel, giving us log of 2002 minus 2 minus log of 2 is equal to 3. Then we minus 2. So we get log of 2000 minus log of 2 is equal to 3. They're both positive non-zero numbers, so they do work, guys. Thank you. We get this here because these two numbers were not 0 or negative. We can actually calculate this and it works. If one of them ends up being 0 or both of them end up being 0 or negative, it's not going to work. Questions on any of this here? We're going to look at one more with like this here, and then we are actually finished with the note sheets for today. So we're doing one more. Now again, with this here, because we have two logs being subtracted, I can write it as a single logarithm with it what's inside being divided. Now, again, since the base for this one was given to us as 4, we're going to put both sides to the base of 4, because our 4, for the log base 4 will, guys, cancel out, leaving us with x over x minus 1 is equal to 4 to the 1/2. And yes, now 4 to the 1/2 will simplify nicely, giving us 2. So we need to multiply by a little bit more than 1. I would multiply by x minus 1. We'll multiply, guys, by the entire denominator, because here the x minus 1 and x minus 1 will cancel, leaving us with just x is equal to. Here we can distribute the 2. 2 times x is 2x minus 2. Well, we can still solve for the value of x from here. But what would we need to do first? So guys, let's focus in. We can minus 2x. So we get negative x is equal to guys. And again, at this point, we could plug it back in and check it, and this is the correct answer. Questions on any of this here? And that is it.